This is a simulation of data acquisition. So in the setup screen, you enter all the project information, the Pi configurations, HPi, the release here, Pi, you can enter in the thickness or square concrete pi. Let's go back to HPi. So let's for this example is HPi. You can enter different hammer. You can filter down based on the model, or you can filter down using the Pi manufacturer, the hammer manufacturer, or you can filter out using the hammer type. So let's keep the same hammer and let's go to, let's start Pi driving. So on the blow number 1, the velocity is perfect. Velocity record is perfect. One right on top of each other. Because of that, you don't see the gap. So we see here, see V1 is exactly the same as V2. Very rare we have this kind of exact V on top of each other. Usually you see a small gap between the two V record. This blow in the beginning here is pretty soft blow. Match quality, instant and GAPA results here. Match quality is not that good. Match quality is 79, is really bad match quality. Let's keep driving, see what happened. So on the second blows, third blows, so all these blows, the match quality are quite bad. It's not very good match quality in the instant and GAPA. Now when you click on this button, either this button or the other button, the scale of the y-axis will auto fit for that blow, for the blow that you just clicked. And that scale will stay for all the other blows. And when you click this, it will auto fit for that blow, for just the blow that we hit. And that scale here will stay for the remaining of the drive until you click again. So until you click again, it will auto adjust to the scale of that blow, of the blow that we just hit. Let's pause the drive here. So you see that all the match quality are not quite good because during the drive, the computer doesn't have enough time to run instant analysis. If we change this to medium match, let's resume. If we change to medium match, the computer will have a little bit more time to calculate, and the match quality improve for some of the blows. But with medium match, the computer takes more time, and because of that, there will be some delay on showing the results on the screen. This is a simulation. This is not a real actual Pi driving. This is simulation. And in simulations, you have to click on in standby so that the blows does not coming in. For the real drive, you do not need to click in standby though. You do not need to click this. As long as though there's no disturbance to the sensors, then there will be no blow resistor. So no actual hammer drive, no disturbance to the sensor, no one removing the gauges, then you can keep this button in drive because there's no trigger, there's nothing trigger the blow. So what would be the best practice to have a good match, good automatic signal match in the field? The best practice is to set the in GAPA to medium match in the beginning and ask for dry fire. So ask for one or two good dry fire. So let's say we have blow number one coming up and blow number two. So we have two blows now. Again, I clicked in standby just because this is simulation mode, not the field. No, I'm not in the field. Right now. I'm in my office doing simulation. So I have to put in standby. In the field, you do not need to put in standby. So the blow number, let me go to blow number one. Blow number one, perfect, pretty good match there with the medium match. Going to blow number two now, which harder blows, more energy to these blows here. Match quality not that good. So for the future blow, all the future blows, if you want to have better match quality, you can do manual match right now. So let's go to GPC review. Go to blow number two. So this is blow number two, and do a manual and GAPA. Click this button here, SOOP, to select all the possible options. In this case, for this soil, if you think that the maximum skin damping is going to be only, for example, 0.3, and you can change this option here, going down to 0.3. So if you go to 0.3, all the futures signal match analysis will force this to be only go to a maximum of 0.3. It will never exceed 0.3 for the skin damping. So let's hit F4. Couple of F4. Let's see if it improved. Not much. The match quality is not that good. Let me manually change something here. And hit F6 here, F6 here. Much all this constant. And then hit F4 now. Okay, this is a little bit better. This skin friction is too much. So change the skin friction for this element to say 70. Still a little bit too much. But let's hit F4 now. Okay, this is much better. Hit another F4. Okay. Let's stay with these results here. So hit this to return to GPC review. And oh, I forgot. Yeah. So in GPC review here, you have to save this GPC review file in order, so save. Click save. In order for this change, you just manually improve this instant signal match for below number two. So you have to save in order for it to update back to GPC acquisition. So we are back in GPC acquisitions, and we are ready to collect the future blows. So again, if on the job side, you ask for a dry file, and if you have enough time to run manual signal match, then all the future blows that the program are going to be collected, the program going to collect, it will have better match quality because it used the model that it was just manually improved. So let's resume and blow number 3, blow number 4, 5, 6. So all the future blows there, the match quality improved significantly. So that's the best practice to run the field data collection. So in one of the blow, you see that blow match quality is 100. Let's go to GPC review to see. So go to here, GPC review, and blow list. One of the blow match quality 100. That is when the program couldn't, the computer did not have enough time to calculate. So it will skip analyzing this flow in the field. You skip this. And it was assigned N-GAPA to be exactly the same resistance as the previous blow, which is 315 here. And it will skip the analysis here. And so that it has enough time to do analysis for the subsequent blows. I did not change anything, so because of that, I do not need to save. Going back, and go back to the data acquisitions. So that's the field practice.
So if in the field the users does not have time, or the contractor doesn't want to wait for the dry fire and they want to drive continuously without stopping, so there's no time for the user to pause for even 3 or 5 minutes to run a manual NGAPA. What do you do? So in this case, you will keep collecting data. You keep collecting data and it will reprocess, reanalyze in the office later on. And this is the case here, where there was no time in the field at all for the user to stop. So in the field, the green line here is the NGAPA field analysis. And the match quality is not that good. See, for the first blow number 1 there, match quality is very, very bad. And click on blow list here. So in blow list, you see that the match quality is pretty bad. Around more than 10 here, and toward the end, let's see, toward the end around 5, 4, 4 to 5, 6, 7. So in general is not here, the match quality here. In general, match quality is not that great. So back in the office, we will reanalyze this, because in the office we have plenty of time. First of all, take a look at the LP table. So the pi penetrations LP table has been kept with quite good record here. The first 4 feet, there's no detailed record of the first 4 feet, but average 110 blows per 4 feet. That is about 27 blows per foot as well. So let's plot per LP. So per LP there, the first 4 feet, you have about 27 blows per foot, and the blow count with depth, they are pretty good record. On the left is LP, on the right is elevation, pi tip elevation, based on the reference elevations that was entered in the beginning. So that plot there would be helpful. If you click print report, it will have that report to PDF with the same, whatever you see on the screen. It will report, you will have the same report. On the left is depth, on the right is elevation, pi tip elevation. So because we have pretty good record of LP, it is better to have blow in the office only, because in the field you don't have the LP table yet. So in the office, it's better to analyze with a blow count match level different than 0. So 0 means no match, the program will not try to match blow count. So whatever higher than 0 for now. So choose blow match level 1 here. We are going to do manual and GAPA for blow number 1, manual and GAPA. Now, in the previous versions of the GPC acquisitions, there is a small box where the PI is incorrectly entered here. So with that, we need to change this first. First of all, we need to change this. Still pi, the PI is 1%. So we need to change that first. Now, the later versions of GPC acquisition, there's no such bug. This is only for one version here. So notice if you see that, you need to change that to the right pi damping parameters. For still is 1%. And click on this check here, so that is the program will do more rigorous analysis. And then just hit F4. So I hit on the keyboard. I hit F4 on keyboard, which is the same as this button there. Match quality improved a lot here. Now the pi divided by default 23 pi nodes, 23 pi node here by default by the program. You don't need to change it now. So with 23 pi node here from in this table here, 23 pi node, the length of each segment is about, in this case, about 3.2 feet, and 6 soil segment. So 6 soil segment here. Let's do another F4. You can do F4 on the screen here, or you can hit on the keyboard F4 on the screen. It improves a little bit more. So I hit another F4 on the keyboard. So let's accept this. This is very nice here. Actually, blow count is not matching well, but this is just a first blow. So the first blow is a very low energy blow, extremely low energy blow. Let me close this, return to GPC review. So with this very low energy blow on the first blow, the set is typically very small, not the average, not the inverse of the average blow count. So in this case, let me go back here. In this case, the calculated blows is very high, which means the set is really low, which may make sense though with this particular low energy blow. So just accept that for now. So the first blow is not that critical. So with that, let's do in GAPA for subsequent blows, which means blow number 2, let's run it. Blow number 2 will be using the parameter from blow 1. After it finishes analyzing blow number 2, it will use parameter from blow number 2 for blow number 3. Let's cancel it for now. So it ran about, when I just did, it ran about 30. Oh, this is elevation. Let's change it to blows. So it ran about 40 blows, there. And let's take a look at the match quality. So really, still really bad, even worse than earlier. So even worse than earlier here. See, the match quality is really worse. So let's see what happened. Let's see why is that. Most likely because blow number 1 and blow number 2 are very different from each other. Blow number 1 is low energy blow, whereas blow number 2 has more energy. And because it's two different, blow number 2 has no benefit from using the parameter from blow number 1. So this is blow number 1, blow number 2, higher energy blow here. So 1, 2. The two blows are much different from each other. So this is 2, back to 1, 2. Now, so when you do instant in GAPA, it will automatically calculate the free length. Okay, so let's go back to see blow number 2 here. So go to blow number 2, and the free length is automatically calculated based on the LP. So LP was 31, and 67.58 minus 31 give you the free length here, 36.58. So only when you run the in GAPA either for subsequent blows or for the all blows, then the free length here will be pulled from the LP table. So let's click this, hit F4. Okay, this is a really nice match here already. Really nice match. Again, this skin friction on this element might be a little bit too high. Let's change it to 80, for example. So it will drop the red simulation. Red is simulation. On this element, hit F6. So it bring up here, hit F6. And then now hit the F. Let me change this to 0.3. Right now this skin damping here is 1.2, which is less than for this geology is maximum is about 0.3. But let's change it to 0.3 for now. So it will apply to all the following blows. So 0.3, which means that during the analysis it will not try any value that is more than 0.3. Hit F4. No, it stayed there. It doesn't improve. Let me F3. Okay, so in this case, F3 will give better results. And hit. Now I'm going to hit F4. Not better than earlier, I think. Oh, this is the best. I didn't remember which is the previous best, but right now this is the best. 1.79. The red is slightly higher than the blue here. So which is this around these two elements. So let's change this to about 17. This 65, and with that we have to increase this. Let's make it 80. Okay. Let's hit F6 here. Doesn't improve. F6 here. F6 here. Okay. Let's try F4 again. Okay. Another F4. The skin frictions looks better, but overall match quality is not does not improve, because later on here it doesn't improve. So the 1.79 is better, even though the skin frictions does not match as well. So let's go to here, 1.81. Let me hit F3. Oh, in this case F3 give much better match here. And hit another F3. Okay, and F4. Okay, so let's stay with this results for now. 1.66 on match quality. This is blow number 2, and return here. So on blow number 2 we have 1.66 match quality. Let's run subsequent blows. So again, when we run subsequent blows, blow number 3 will use results from blow number 2. One blows number 3 is done, then blow number 4 will use the result from blow number 3. And when blow number 4 is done, blow number 5 will use results of blow number 4. Let's cancel here. So during that time, it finished about 56 blows, 56 blow there. And let's take a look. So 56 blow here, all match quality are good. So by looking at this, you see that it finished the oh, actually one of the blow the match quality is not that great, but then is improving on the next blow. So it finished 59 actually. It finished 59's analysis there, and the last one that it ran magically is 1.58, and we haven't gone to the program haven't gone to the blow number 60 and so on and so forth yet. So these magically are the old magically. So select 59, hit OK, and the selected blows cursor will be on the end of that previous run. All the subsequent here are the previous results. All these subsequent here are the previous results. So hit manual and GAPA. And on this, it looks pretty good. So most likely the F3 or F4 will not do much improvement. A little bit, but not much more. So I'm keeping it to either F3 or F4. So it will stay here. Oh, no, it's not. So it doesn't improve much. Skin frictions looks okay match here. So let's accept this and run in GAPA again subsequent blows. So it will run blow number 60. It will run blow number 60 based on blow number 59, and so on and so forth. So it will keep running. And so this. And so it's finished running to around blow 150. Analysis to around blow 150. Let's take a look. So going down the list here, it finished analysis to around blow 154 actually, on blow 154, magically 1.57. The next one here that it has not gone into yet. So select this, hit OK, and do a manual N GAPA. See if we can improve this. Most likely not, but let's give it a try. A little bit, not much. There's no room for manual improvement here. So let's accept this and resume this subsequent blows. Let's cancel this analysis to see where it go. So it finished to around blow 460, and you can hit here blow 460, blow 459, naturally 1.14, manual and GAPA for that blow, and everything looks pretty good. Again, the free L here is automatically assigned by the program only when you hit that in GAPA button. When you hit the manual in GAPA, just like I did, it used the in GAPA run. So the in GAPA run calculate this. And let's see if F3 or F4 improve this. So it improved just a little bit, not much. So accept this results and then resume our adventure. So here, subsequent blows, it will start from that blow 460 based on the results of blow 459. The reason is based on 459, and because we just manually improve the N-GAPA of blow number 459. So the analysis is done for all the blows. Right now the vertical plot filter point is 4. We can use less than 4 here. Let's use 2. This is when it is pause. Let me see how long is the pause. So here, where the strokes is not detected, the stroke is not detected when there's a pause in the pi driving. So the timestamp is 2:27:45. The previous blow is 2:25. So a pause of 2 minutes. A pause of 2 minutes. So with that, the low energy. So after the pause, this blow is a low energy blows. It can be turned off. So let me turn off that blows. And this one, the match quality of the analysis is not that great because it used the low energy, the results from the low energy blows of this. Earlier it ran, I just turned it off, but it used the low energy analysis of the blow 553, and because of that, match quality of this blow is not that good. So what you can do is going back one more blow, which is this blow 552. Do a manual N-GAPA here, and do a manual N-GAPA here. Hit F4, F3, F4. Okay, let's accept this result. 0.92 match quality. Accept this, and then run subsequent blows. From blow 552 to the end. In the futures, you can exclude the post blow in advance. That way you don't have to rerun it. So when you exclude blow 553, it will pass through that blow without doing analysis, and because of that, blow 554 analysis is based on the analysis of blow 552, and the automatic analysis is much faster and with better match quality. So we are done for this N-GAPA for the whole drive. Let me save this and explain a little bit more on the soy segment. So for example, blow 554 here. So by default, the pi has been divided by 23 node. You can increase this node so that the length of the segment is smaller than the default here. So let's say, for example, you increase to when you type some number here, okay, for example 40, the program will change it to an odd number. So accept whatever the program suggests. So it will rerun this whole drive. Is much slower though, much slower. 41 node is almost double the initial node. So with this automatic analysis with 41 node, this segment is now 1.7 feet instead of 3.2 feet. Match quality doesn't improve that much, and it is slower. It is a slower analysis. It's taking much more time. Let's hit F4. F4 is also much slower with more node. So the match quality degraded the reason is it's trying to bring better blow count toward the 40. So go back to best. So we still have the best results there. The best results is with 23 pi node, 6 soil segment. So 6 soil segment is here. The current analysis is with 41 pi node and 14 soil segment. So the soil segments will always the soil segment here will not change when you change the field length though. The purpose of this is so that the whole drive from blow number 1 to the last blows, it always have the same soil segment. The only difference is the free length between blows to blows. The only thing that differs is the free length. That way it's easier for the program to handle. Now going back to the base here, you can change these the soil segments to be a little bit different. The program will, for example, type 20. It's not going to accept 20 though. So the program will say, hey, maximum you can use is only 8. For the in the case of 23 pi node, the program only accept maximum 8 there, and this will give you different match quality. So here 8 segment. If F4 is still not the best, not as good as it used to be on a 6 soil segment. So this is with 8 soil segments, and let's take a look at the free length. So so the total length is 67. If I put, let's say, if I put free length of 60, okay, if I put free length of 60, all the skin resistance above approximately 60 will be automatically assigned to 0. So 60, that 60 is happen to be between these two nodes, and so that from 60 to 64.4 there is skin friction, and for simplifications of the analysis it averages out on that segment. So with this, it will not be able to enter any skin friction here. It will always turn back to 0. So you will not be able to have any skin frictions above the elements that contain the 60 foot mark. So the element that contain 60 foot mark is from 54.7 to 64.4. 54.7 to 64.4 is the elements that contain that foot mark, that 60 foot mark there. So it will the program will force skin friction to 0 for all those elements. You will not be able to enter any skin frictions manually, and as well as when you run automatic analysis, it will never has skin friction in those elements. So that's how the free length and the soil segment work. So soil segment never change. It's just that these elements above this above the ground line will never have skin friction. So notice that if you change this node, the number of pi node. So let's change it to 25, and if we change this number of pi node, let me change this. So for this thing again is all 0 here. If I change this to 10, and so when you manually change to 10, it does not do any analysis yet. You have to hit F4. Once you hit F4, this will automatically assign some skin frictions because now it said that above 10 there's no skin friction. So from 10 to the pi toe, there's skin friction, and and from 10 to 14 here, it has been averaged out on that soy element there. So with this, it has different number of pi node than the rest of the drive. Typically, you don't want to do that though. But if you prefer this, and when you return, it will say, hey, number of pi node has been manually changed on the later blows, and the program was not able to update the results. So it will reverse. It will reverse back. It will reverse back to the previous analysis. It will not accept your change. So that's it for this demonstration.